Okay, hi everyone. This is the video for part 3. So congratulations on making it to topic 9, part 3. Yeah. Okay, basically in part 3, I think in part 1 you have gone through the N-choose-R notation and how to do factorial. And in part 2, you have actually used the binomial theorem. Okay, so in part 3, basically, how do we go about finding unknown coefficients? Okay, also sometimes the idea of the general term, okay, let me just try to minimize the echo. Okay, is that when you, give me a while, okay, let's hope it all goes well. Okay, so basically, when you are finding, let's say if I give you a whole expansion and I want you to find the unknown coefficient within a series, list of terms. So for example, maybe you expand up to 11 terms, and I ask you to find the fifth term. I ask you to find the sixth term, or I ask you to find a certain unknown coefficient. Okay, it may be a bit challenging. You may think that, oh, you need to expand every single term just to find the fifth or sixth term. So the thing is actually no need. Okay, you don't have to do that. So how do we go about finding the middle terms or unknown coefficients? Is by using something which we call the general term. General term basically is like a form of how all the uh, terms in the binomial expansion will look like. Okay, so this is in general what it looks like. If you see, it's actually term r plus 1, okay, compared to n choose r, a to the power of n minus rb. Okay, what does it look like? So if you remember, when we expand a plus b power n, okay, this is basically a power n plus n choose 1, a to the power of n minus 1, b power 1, plus n choose 2, a to the power of n minus 2, b power 2, plus n choose 3, a to the power of n minus 3, b power 3, so on and so forth, until you have this n choose r, a to the power of n minus r, b power r. Okay, so far? Then, I mean, you can see that this will be my term 1, right? And when this is 1, is actually term 2, right? It goes the second term. And when this is 2, this is actually term 3, right? And when this is 4, this is 3, sorry, this is actually term 4, right? So in case you're wondering, this is actually, you guess it, this is R, this term would be term R plus 1. And this is actually a generic form of all your terms when you expand them. And we call this the general term. But it's not term R, remember, it's term R plus 1, okay? So that's what it looks like. And then R, of course, cannot be greater than N, right? Right, because I mean, the greatest value of R will be equals to N, right? Because you cannot have 5 choose 7, right? The most 5 can choose 5, that's all. You cannot choose 7 things from 5. So R has a limitation, it cannot be more than N. Okay, so do take note that this formula is not in the formula list, it's actually not given. Okay, yeah. So why do we use the coefficient? So let me give you an example. Let's say you look at question 3.1. Okay, so for example, if I ask you to find the middle term in the expansion of x squared minus 1 over x, how do I go about doing this? Okay, so you know that there are 10 terms, power 10, right? How many terms would there be? 11 terms, right? So 11 terms. So when you look at 11 terms, the middle term will be the sixth term. Okay, so you have 11 terms. I don't have 11 fingers, but I mean, the middle term will be term number 6, right? It's basically so-called term number 6, right? Okay, so if you think about it, right, you look at this, x squared minus 1 over x. Okay, so you just treat this as your n, this as your b, so-called this whole thing is the b, and this one is the a. You can see that my general term, which is so-called term r plus 1, is equals to, I mean, like 10 choose r, a to the power of n minus r, and b to the power of r, right? So what do we want r to be? So remember, we are finding term 6, okay? So it means that you basically want this, You want this to be 6, right? You want r plus 1 to be equals to 6. Fair enough? So it means that r is equals to 5, right? So very simply, take this and you sub r equals to 5. And what you get is a very nice, complete numerical term, 10 minus 5 minus 1 over x to the power of 5. And you work it out, it's going to give you a very nice coefficient, negative 252 x to the power of 5. Okay, so the middle term, straight away, without expanding everything, you can see that the middle term is just negative 252. Okay, which is fantastic, right? You don't need to expand everything just to find the middle term. You can straight away use the formula to pull out your middle term. Okay. So next, we are going to look at part B. How do we find the fifth term when expanding in ascending orders, powers of x? So if you look at this, right, if I treat this as A, remember this is a positive power, but because it's A, as I go down the expansion, it's going to be going down, right? It's going to be descending, right? And this is going to be ascending, right? And this will cause the power, because it's 1 over x, right? It's going to cause the power to go down even more, right? So if I want to expand in ascending powers, maybe it makes sense to swap the two terms, because I want this to get smaller and smaller. I want this to get bigger and bigger, right? So that's what I'm doing. Instead of writing it this way, I'm going to write it as x minus 1 over x plus x squared. Okay? And because you know that if I treat this as my A, it's going to be dropping in powers. This is my B, it's going to be increasing in powers, right? Because of the R. So this is makes more sense if I want to do it in ascending orders. Okay? So I want to find the fifth term. How do I do that? Well, very simply, it means that you want the fifth term, right? It means that basically you want term 5, right? What does it mean? So remember, this generic term is term r plus 1. It means that you want your r to be 4, right? Your r to be 4. So very easily, your term 5, just follow the formula, then n choose r a to the power of 10 minus r b to the power of r. Oh, sorry, let me put 4. Okay, so let me just simplify it. You have 10 choose 4 minus 1 over x. 10 minus 4 is just 6 multiplied by x to the power of 8. And everything will turn out very nicely. So you're going to get 210 x squared. Okay, so that is how useful the general term is. It basically shortcuts a lot of expansion if you're just finding one term, correct? Because you want to find one thing, you don't have to go and ransack the whole room, right? You just need to use a general term and you can pick out whatever you want. Okay, it's like a filter. Okay, so let's look at C. I want to find the term in x power 11. Wow, so don't know how to do, but don't worry. So the thing is, when you have a general term, it's very useful. It can help you to find coefficients. Okay, so remember the generic term basically was something like this. It was like something like 10 choose R. And you have the generic term. I'm just going to use this term here. Regardless of whether I'm swapping or not, I'm just going to treat this as my A. So over here, my A is going to be, hold on a second, like XA is my A to the power of n minus R. My B. Okay, it doesn't matter whether you do ascending or descending because you are interested only in the power of 11. So this is what your general term will look like. Okay, so wow, you know, what do I do next, right? Okay, the idea here is you want to find your R. Okay, your mission is to find R. So what you do, number one, okay, of course you form your general term. You form a general term. This is step one. You form a general term. So step two, what you do is so-called you collect. You collect all the terms of x together. The terms with x together. Okay, what do I mean? Okay, so you see, I'm going to do next. Very interesting. So I'm going to take 10 choose R, x. Okay, this is by indices. A power m bracket n is a power m times n. So this is going to be 2 multiplied by 10, 20. 2 multiplied minus 2r. Over on this part, this is going to give me something like negative of x to the power of r. Okay, so because of the negative signs, a bit sticky, I'm just going to write this as minus 1 power r, x power r. Okay, ma? Can, huh? Okay, so with that, let me just put, this is what I mean. I want to collect my x term. So I want you to see that I'm going to bring these two together. I'm going to collect, this is what I mean by collecting. I want to collect them because I'm a x collector. Okay, so this is x 20 minus 2r and r. I have x to the power of 20 minus 3r. Easy, right? Step 3. So after I've collected all the x, so number 1, equate the power of x to what you need. To what you need. Okay, so in this case, right, you realize that I need x power 11, right? Because in this case, it's x power 11. And you know that after I simplify, or I've shown you that all your general terms look like that. And you want x to be 11. So if I want this to be 11, what does it mean? It means I want this to be 11, right? This can be 11, right? So in x power 11, this guy is equal to 11. Okay? What does it mean? It means that for the x power 11 term, so-called, okay? It means that this guy, your 20 minus 3r is equal to 11. So solve this, all right? You get 9 equals to 3r and basically r equals to 3. Damn easy, all right? So with r equals to 3, what does it do? Fantastic, right? It gives you straight away clearance, a clear vision that, wow, you know, once I take this, right, I just sub. This is basically 10 choose 3 minus 1 power 3, right? And I mean, if you sub, definitely you're going to get x power 11 for this guy. Okay, so this is basically your term with so-called x power 11. And you can see that this is going to give you basically your answer comes out very nicely as negative 120 x power 11. And we are interested in this. Our coefficient of x power 11 is negative 120. Can? Yeah, so basically I go through the 4 steps. I think this is very important. You definitely need to do it a lot. Okay, so basically just solve for r and sub it back into term r plus 1 to find your general term. You might want to take this down and calculate it. I mean, to find your so-called coefficient, maybe. I'll say find your coefficient. Okay, so just take this, follow these 4 steps and you will never go wrong. Okay, so next one, basically the learning point you must know that is to identify correctly the value of r, remember, and also to apply the general term formula. Okay, so remember the 4 steps. Form your general term, collect all the x terms outside, identify correctly the power of x, equate it to your whatever term you need, power 11, power 0, or what. Okay, or sometimes they'll put independent of x, then solve for r and sub it back into a general term. Okay, so I'm just going to go through question 3.2 as well. Okay, very easily. If I look at this, right, I treat this as my A, I treat this as my B, I treat this as my N. You can see that my term r plus 1 or my general term will be N. Choose r, A to the power of N minus r, B to the power of r. I'm going to leave it like that. Okay. Okay. So next up, we need to basically maybe try to collect all the x terms okay, before I use it for part A, part B. Maybe, let me beautify my general term. Okay, so same thing. Number 1. Okay, see, I form my general term. Follow my step. Number 2, I collect all the terms of x. I collect all the terms with x together. Okay, gather them. Okay, like one brotherhood. 9, choose r. Again, same indices, x to the power of 18 minus 2r. This is basically 2 power r, x power minus r. Okay, I split these two guys up into this and this. Okay, so now this and this comes together. So this is 9 choose r, 2 power r, x to the power of 18 minus 3r. Beautiful. So step 3. A, you see, I want to find the term independent of x. Independent means what? Don't have x lah. You say you independent of your parents means you don't need your parents, right? Okay, to survive lah. I'm independent of that person means we don't not related. Independent of x means doesn't depend on x. Don't have x. Okay, so it means that which term will be independent of x? Well, it's just a constant, right? So that means your x power 0 or the constant is the guy you are looking for. Okay, so very simple. Okay, equate the power of x to 0. Okay, you can see 18 minus 3r is our power here, right? I'm going to equate this to 0. Straight away, you get r equals to 6. What does it mean? Well, your r equals to 6. That's your answer. That is the answer to provide you. Okay, so sub r equals to 6 to find your answer. Okay, sub r equals to 6 to find your answer. Okay, so with that, you know that just fine. Okay, so term, because r equals to 6, you're looking at term 7. That is 9 to 6, 2 power 6 x to the power of 0. Okay, so I basically sub r equals to 6 into my generic term, which is very useful, and I get my answer to be equals to a very nice turnout, which is 5376. And this is the term independent of x. It does not contain x inside. Okay, so you will definitely see this very often, independent of x. Okay, so if no questions, I will go to part B. Okay, so part B, same idea. I'll just write it here now. Maybe get a bit off listing, but you can see the coefficient of x cubed. It means that you are looking for the term with x cubed. All right, so remember this is our generic term, right? I still have my step 1, step 2, but now very different. Your generic term is here, your general term is here, which is 9 choose r, 2 power r, x to the power of 18 minus 3r. And now the step 3 has changed. Basically, you are going to equate your power of x. Because you are looking for x cubed, you must equate this to 3. Okay, so far, all your terms will be of this form in this expansion. They will all look this form. And now you are interested to find the coefficient that contains of x cubed, which means I want this to be 3. And I want to find what is r. And I want to take the r and I sub that inside, which is my 4 steps of the r formula. Okay, not formula, sorry, of finding the general term. Okay, yeah. Okay, so from here, you basically do equate the power, which is 18 minus 3r. Equate this to 3. 15 equals to 3r, and r is equals to 5. Nicely. Okay, so that's for part B. And then step 4, well, very easily. So step 4 again, sub r equals to 5, sorry, to find the coefficient of x cubed. So very quickly, okay, just to demarcate, this is my part B, so very easily, the coefficient of x power 3. You can see that I just basically sub r equals to 5 here. Okay, so very easily, 9, choose, my r is 5, 2 power 5. This is going to be x cubed. I'm just going to ignore it, friend zone to one side. Your answer is 4032. Okay, easy, right? Okay, general term sometimes students will have difficulty. Like a lot of time you all may forget easily. So my advice is go through the 4 steps. Okay, remember what I say. Find the general term, collect all the x terms, equate the power, and then you solve. Okay. So with that, I hope you are comfortable with this part portion, and we look forward to seeing you in IREP. Thank you.